2, and 1. All right. Now, we are going to go into topic 8.2. Now, as we progress further, we're going to be first we're looking at our strongs together, our weaks together, and exactly how they all combine eventually into one to create the different stuff, which is the basis of everything else that we'll be doing later on, especially when it comes to titrations. We want to know which is our titrant, which is our analyte, our equivalence points, half equivalence points, pKa, pKb, everything is when they all mix together. All right, so today we're talking about our PAR, strong acids, and our strong bases. Now, our strong acids and bases will completely dissociate or ionize in water. So they're going to completely break up in water. Now, in doing so, they actually become electrolytes by doing that. Now, electrolytes are elements or solutions that can actually conduct electricity. So a lot of those things that we drink are like, oh, it has a lot of electrolytes. Well, if we conduct at least a little bit of friction with electricity in our body, gives us the energy and the metabolism to be able to recover from workouts, to want to do things, to actually get some energy of some sort going. Now, the reason why having a lot of those energy drinks is kind of not great, because it does have a lot of mixtures of different electrolytes together, and too much electrolytes in one can, do a lot of stuff. I did see this YouTube video once. There was this guy who drank like 8 Red Bulls, and he went to the ER, and you can see his heart literally like jumping out of his chest because of all the energy drinks that he had. Anyway, sorry about that. Okay, so they can completely break apart in water to create an electrolyte. All right, remember our strong acids. Now, the lingo that the mnemonic phrase that I know again is for strong acids, so I brought no clean clothes. I know that there's another one that actually uses the full symbols of everything. I'm not too sure what it is. My last class told me what it is, but I forgot. But there's another mnemonic phrase as well. I think Fernando Sanabria has it. You can always ask him what it is. All right, so again, if you recall, our 6 strong acids are hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen nitride, hydrogen sulfate, and hydrogen perchlorate. All right, now, since they dissociate completely in water, again, they are very strong electrolytes, meaning that they can conduct electricity when they're in solutions. Now, when we are trying to determine our acids or our concentrations, our pH, or whatever it is, or pH or H for our strong acids, we are going to be using this type of rationale, which are concentration of our ion is equal to our acid. All right, now there is a word that we are seeing here, monoprotic. Now, I think it is in 8.3 or 4 we talk about these things. Now, monoprotic means is that when we look eventually at a titration curve, we're just going to see obviously just one curve in there. We also have diprotic and polyprotic as well. Di meaning 2, poly meaning many, and we'll get to that later. All right, our strong bases also completely ionize or dissociate in water. Now, which one you use on in your vocabulary is completely up to you. Ionize, dissociate, it's the same thing. One sounds fancier than the other. Again, our strong bases are everything in group 1 except for hydrogen and francium. And then in group 2, it is up to, is barium included too? Yes, it is. It's everything except for radon in group 2. For the most part, magnesium is one that could also be considered a strong one as well. It's not often really used, but in our assignments and things that we see, if magnesium is included, since it's part of group 2, it can also be considered a strong acid, base. All right, yesterday we used our little square thingy to calculate our pH, pOH, and all this stuff. Do we have any questions on how to do that at all? No, right? It was easy to do? You didn't get stuck anywhere? Okay, cool. We're doing a lot of the same thing here today, but we're dealing with our strong acids and our strong bases in general. Now remember, when it comes to total of everything, we know that if we added our pH and our pH together, they should equal to 14. So usually that's my relationship between pH and pOH. So if we have one, we can easily guess the other. Now, let's go over my acids and bases. Okay, if I have a pH of 4, is that an acid, base, or is it neutral? Acid. What about 11? A 7? 7.2. Base. Excellent. Remember, for it to be neutral, it has to be exactly 7 on the dot. If it is higher than 7, it is an extremely weak base, but it's there. Okay? All right, now when we are doing things with our strong acids and our strong bases, we always have to be very watchful of everything that we actually have. All right, so especially when it comes to our bases and even our acids too, we have to pay attention to how much there actually are. Now looking here at this example, it says that what is the pH of a 0.010 molar solution of barium hydroxide? And here we are. Now this concentration is technically just for one hydroxide. But here, how many do we have? 2. So we have 2, and we know this is the value of 1. How are we able to get the total how much we have? We add them together. Or you multiply times 2. All right, here, that's my concentration. From there, we would jump forward for everything. All right, so we're gonna be watchful of how many hydroxides we have and how many hydrogens we have in our stuff, because that concentration it gives you is just for 1. If you have multiples of them, you need to, what's that word? Adjust your concentration. There we go. All right, cool. Now, I ran out of whiteout. Go figure. I use this black thing here on marker. All right. So let's go ahead and let's take a look at what we have here. All right, so number 1 is asked you to find the pH of a mixture of a 10 milliliter of 0.00100 molar solution potassium hydroxide, which is KOH, and a 10 milliliters of our distilled water. All right, now to find our concentration, it is molarity times volume divided by our total volume. All right, this is something similar to what we've done when we talked about solutions in one of our units. I don't remember which one. All right, so let's go ahead and let's do our stuff. All right, we have a 10 milliliter volume, and we have a concentration of this here. All right, so it's going to find my OH concentration. All right, so we're going to multiply my molarity times my volume. So we have 10.0 milliliters times my concentration, which is 0.00100. Let's go ahead and do my total volume. Now, in this case, we don't have to convert over to liters because a lot of the stuff that we do when it comes to solution is in milliliters rather than liters. So we'll leave it at that. All right, so initially we had 10 milliliters, and then we added 10 milliliters of distilled water. So what's 10 plus 10? All right, tell me, what is my concentration of OH? All right, what do you get? Point what? Be faster with our math skills.
0.005.
How many zeros?
2.
You sure? Yes? Is it 2 zeros?
you're wrong.
divided by 20.
It's times 10, negative 10.
It's the same thing. Alright, I got my concentration to be 5 times 10 to negative 4 is my concentration. The answer that I have is the same thing as if this is just in scientific notation. If you'd done the other way, it should have been 3 zeros in front of 500. Alright, cool. We have my OH concentration. Is it asking me for OH concentration? What is it asking for? pH. Great, now I have my OH. Now, can I convert my OH to pH? Straight up? No. What's the first step we're going to do? From OH, what do we convert to? POH. Excellent. To go from OH to POH, what is my formula for that? Look at your square.
Negative log, and then
Negative log of my concentration, which is 5 times 10 to the negative 4th. Negative log of that answer, and I get 3.30. Great, now I'm at POH. Can I go from POH to pH? Yes, I can. We know when we add pH and POH together, it equals to 14. So 14 minus my POH, which is 3.30. My pH is 10.7. Questions, comments, concerns? Okay. All right, let's look at my redo. All right, how would you adjust a 100 milliliters of sodium hydroxide solution with a pH of 12 to a pH of 11? All right, so quick thing here is that we have a sodium hydroxide solution, but we're given pHs for each. Now, when we're thinking about pH, it is percent hydrogen. All right, now, would percent hydrogen work for a base? No. All right, so let's go ahead and see first our differences, and let's get our concentrations for each one. So what we're going to do is we're going to convert both pHs to POH, because it wants to know how we can adjust something. So we have to be able to have a volume of our water to add to our solution to adjust it to change our pH from 12 to dilute it and drop it into a pH of 11. All right, let's go ahead and convert both pHs over to my POH. All right, so let's go ahead and start my first one. I'm going to do POH. All right, from pH to POH is 14 minus my pH. What is 14 minus 12? 2. Great, let's do my next one, POH. It's 14 minus 11. What's 14 minus 11? 3. Great. We now have our POH. Now, our second step is to convert our POH to OH. We need a concentration. This question wants us to dilute our solution. Now, if we remember from way back when, my dilution formula is the molarity and the volume of one is equal to the molarity and the volume of my second one. All right, so we need to have a concentration because we need molarity in order to make it all work. All right, now we're at POH. We can go to OH from there, correct? Yes, we can. All right, so if we wanted to go to our OH concentration, what is the formula to go from OH to POH, from POH to OH? What's my formula? Excellent, 10 to our negative POH. So here 10 to negative 2 and 10 to the negative 3. All right, so 10 to the negative 2 is 0.0100 as my concentration for my OH. My first. Oh, wait. Oops, I wrote it up here. This one should be for this one. My bad. And 10 to the -3. I have 0.00100 molar OH of my second one. Great. I went from having pH to POH, and now from POH I went to a concentration of hydroxide. Now, since it's asking us to drop our pH level, going from a 12 to an 11, we know we need dilutions here. We need to add water to be able to do that. All right, so we're going to use our dilution equation to kind of make that work. All right, so let's go ahead and do my dilution equation, which is molarity and volume of 1 is equal to molarity and the volume of my second one. All right, my molarity of my first solution is 0.0100. And the volume I have here is 100, 0 milliliters. All right, let's go ahead and do the second part. Now my second concentration of my water that I have is 0.00100, and I don't know how much volume I need to be able to offset it. All right, y'all. So go ahead and tell me what is going to be my second one. Third step, use dilution equation to see All right, what is my final volume that I should have after everything? What is it? This times this divided by that, what do we get? Great. Our total volume has to be 1,000 milliliters. Great. We know we have to have 1,000. Now, last step is we're going to subtract our final volume from our initial. We need 1,000, and currently we're at 100. If we need 1,000 and we only have 100, how many milliliters of water do we need to add? 900 milliliters. Questions, comments, concerns? We went from pH to POH. We went from pH to OH to find our concentrations. Since we're dealing with dilutions, we use our dilutions equation to determine how much water we actually need to have total, and then adjust it from there. All right, the last thing I'm going to leave you off with, because it's not as complex as those two questions, is I do want you guys to look at number 3. All right, it is very similar to everything that we've just done. It's asking you who's going to have the lowest pH. We have 2 bases here. Now, remember, now we're taking into account how many of the hydrogens we have and how many hydroxides we have. Because again, a concentration it gives us is just for one of the H or one of our OH. So let's compare these two, potassium hydroxide and calcium hydroxide. Between the two, what is the difference between these two bases?
There's 2 hydroxides and calcium hydroxide.
Excellent, there's 2 here. So So my concentration for just one calcium hydroxide is this one, but we have two. How will we find my total concentration? Multiply by 2. All right, pay attention, be careful. All right, any questions at all? Similar math to everything we've already done yesterday. On Friday, I'm going to give a retest to this atrocity that happened this morning today. Shame, 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 except for like one of you. High five you, nerd, you know who you are. But everyone else, WTF, that's all I can say. WTF.